Hello everyone, welcome back to Let's Unbound. Yes, we are in fourth part of Unit 1, Concept Overview plus Problem Solving. So yes, it's 2.4 Exponential Function Manipulation. Let's get into this. Exponential function manipulation means there will be many processes like transforming functions, simplifying, solving, graphing. And so like this exponential manipulation had some techniques and we will see how it is. Mostly the transformation of exponential function have very important and remarkable manipulation techniques here. So let's understand that. First one, we know the product property of exponents. A power m times a power n is a power m plus n. Now, I can relate it with horizontal and vertical dilation. Let's see how. So let me start with a basic function b power x and I apply a horizontal translation by adding a c. B power x plus c. Now using this rule, you can expand it. B power x times b power c. B power c is just nothing but a number like any constant. So I am naming it as a. B power c, let it be a. Now, I started with a simple function. I applied horizontal translation. I applied this property. I got a new kind of exponential function. Not a new kind, like it's just b power x with a multiplied. If you multiply something before b power x, it's vertical dilation with scale factor a, right? So horizontal translation can be manipulated and you can show it as a vertical dilation. So they are equivalent. Every horizontal translation is equivalent to vertical dilation here for an exponential function. So this is one manipulative here. Now moving to next part, product property. Actually I want to show you the graph. So this is 2 power x. I took one of the graph. Now I applied a translation. Okay, I move left, right. So this black is 2 power x plus 3. Right. So this black and red are exactly same. Like this is 2 power x. And if you graph 8 into 2 power x, how this 2 power x plus 3 is horizontal like shift. 8 into 2 power x is vertical dilation. They are one another same. So you can write it as 2 cube into 2 power x, 8 into 2 power x. Okay. So this is what, this is how you can see this graphically. Now, power property of exponent. Power property means power to the power, you multiply the powers. Horizontal dilation, f of x is bc power x, b power cx. Like if it's b power x, you just multiply c, it's horizontal dilation. Now I'm applying the rule, b power c the whole power x. B power c is a number, so I'm just giving a different name, a power x. So I start with b power x, I do the manipulation, now I got a power x. So what had been changed here? The base completely changed, correct? But still, they are equivalent. Every horizontal dilation is equivalent to the change of base. That base, we should find it while we are manipulating. It's not like any base, correct? So this is the second manipulative. Now, here the graphical way. If this is 2 power x, again prove with this, then you're dilating 2 power 3x. I multiply by 3. I got this black one. And it's that this red one is nothing but 8 power x, and this black and red they do the same. But I used different way of graphing, like just the analytical form is different, but graphically they are same. Right? Now, negative exponent and unit fraction, this will be helpful for us while simplifying like algebraic things in exponential forms. A negative exponent indicates reciprocal of base raised to. Very simple. Mostly we will need positive exponent. So how to convert a negative exponent to positive? Simple. Reciprocate the base and change your negative to positive. A power negative n, you change to 1 by a, and minus n will go positive n. And this is simplest form because 1 power anything is 1, and a power n is a power n. Here a cannot be 0 because we are reciprocating, right? And in case if you got something like this, 1 by b whole power negative n, again same process. You want positive exponent means reciprocate the base. 1 by b will become b and minus n will become positive n. Right? Now fractional powers, any base whole power 1 by n, you can write it in third form, nth root of a. For example, if you have 8 power half, it means square root of 8. If you have 8 power 1/3, it means cube root of 8. Okay. So these things also we should know. This will be helpful to us. Now, first question, let f of x equal to 2 power x. And then define a new function, f of x plus 1 the whole power minus 2. Then name the transformation. Okay, let's start with the first one. F of x plus 1 means what? Which is 2 power x plus 1. So it's a horizontal shift, right? I'm adding with x. So it's horizontal shift 1 unit. Okay, to the left or to the right? That's the next question. So if it's plus 1, be careful. It's left, not right. Correct? So horizontal shift. Right, now I'm squaring it. F of, not squaring, I'm raising it to the power negative 2. So here you need to apply the math because raising to the power means like what kind of transformation rules we know? We don't. Adding, subtracting, multiplying, we do that, right? So for this, you have to do this manipulation. 2 power x plus 1 is your f of x and you raise to whole power minus 2. Power to the power, how will you do? You will just multiply the exponent. 2 power minus 2x minus 2. Okay, I write in simplest form. Now I will break down. So if you have a negative before your x, it's a reflection towards y-axis. So negative 2 is representing that negative says reflect across or over y-axis. And what is it 2? 2 multiplied will give you horizontal shrink. No, yeah, horizontal compression, right? So horizontal compression that 2 says. Okay, by scale factor, you should reciprocate 1 by 2. So don't forget to mention scale factor, and also for horizontal, you should reciprocate it. And minus 2 means it's a vertical. Okay, actually minus 2 in the sense, I'm going to manipulate this one. Like how means 2 power minus 2x into 2 power minus 2. I split it. 2 power minus 2 means 1 by 4 because 1 by 2 square if you want to convert to positive and 2 power minus 2x. So 1 by 4 into 2 power minus 2x. So this is also one way. So I can say I applied this reflection, horizontal compression, and 1 by 4 is vertical dilation or vertical compression again, right? Because it's 1 by 4. By scale factor 1 by 4. Right? So this is the thing, shift 1 unit left, reflect across y-axis, horizontal compression, vertical compression. Like vertical shrink, you can say. Right. So that's the first question. Now, here we go. Let f of x is equal to 3 by 5x by 5 power x by 4. Find f of minus 2. Very simplest one. Just you have to plug in 3. Wherever x comes, put minus 2. So f of minus 2 is 3 by 5 power minus 2 by 4. And you can always simplify your exponent. So 5 power minus 2 by 4 is minus 4. I want to make it positive. So 3, you can take this 5 to the top and it will become positive. Okay. So 3, you don't multiply 15 whole power half, it's wrong. So 3, it's 3. 5 power half, you can rush or you can write it in this form. And rationalize your answer, but it's already, the denominator is rational, right? So that's not needed here. So it's 3 root 5. Right? This is the simplest form, and we are moving to the third question. The population of bacteria is placed in a laboratory dish. Scientists observe the bacteria count over several hours. The table shows the population at various times since the beginning of the experiment. The population of bacteria can be modeled by this exponential function where P of t is population in thousands at time t hours. Write an expression for P of t. Okay, I need this table. So using table of values, how can you write an exponent relation or an equation? Okay. So if it's initial 0, that is always your a into b power exponents, that is your a. Okay. So now my function is P of t equal to a into b power t. So you can plug in 0, 5 is in your function. So 5 equal to A is A only, B is B only, T is 0. B power 0 is 1, so you will get A equal to 5. So A is 5. Now your function transform to 5 into B power T. If you find B, the function will be complete. So you can plug in another value like 1 comma 6.5 in this new equation. So 6.5 equal to 5 times B power 1. 6.5 by 5 is B and B is 1.3. Basic simplification, and that's it. Your P of T is ready. P of T is 5 times 1.3 whole power T. This is the exponential model in equation format. Right. Next question is, okay, there is one more, right? Find the rate of change from T equal to 2 hours to 4 hours. Very simple. So rate of change, average rate, right? So it's P of 4 minus P of 2 divided by 4 minus 2. And we have P of T actually, 5 into 1.3 whole power T. So we can just start substituting. 5 into 1.3 whole power 4 minus 5 into 1.3 whole power 2 divided by 4 minus 2. And you can start simplifying or you can use calculator for this. I'm just ignoring this now. So you will approximately get 2.9125. And what is this? Actually, population is in thousands. And T is years or hours. Wait, it's not. I think it's hours. Yeah, it's hours. So 1,000 per hour. 2.9125 thousands approximately per hour. So while you're writing rate of change, this unit is important. And that's it of today's video. And yes, I have a bonus question. So read the question. If you want to reiterate some concept, you can rewatch the video. And if you have any doubts, questions, you can post in comment box. So do solve this and also post your answers. Try posting your answers in the comment section. Thank you so much. And again, a reminder to join Let's Unbox Student Community WhatsApp group. Okay, you can scan the QR code given here. Thank you. I will be meeting you next video very soon. Until then, keep learning, stay curious.